Good morning students, I am P. Gomati, Assistant Professor, Department of Mathematics. So in this lecture we are going to see the problems in Green's theorem. So in the previous class also we have seen the Green's theorem problems. So there we have seen about the evaluation, but in this problem we are going to verify Green's theorem. So now let us tell me the question. Verify Green's theorem in the plane for integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy, where C is the boundary of the region defined by x equal to y square and y equal to x square. So if you want to verify Green's theorem, you have to verify both left hand side and right hand side. So first separately find the left hand side and first find the right hand side. Check whether the answers of the both left hand side and right hand sides are equal. So now let us write the statement of the Green's theorem. So what is the statement? So by Green's theorem, we all of you know that the single integral is equal to the surface integral. So that is integral over C m dx plus n dy is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy. So given equation is integral over C 3x square minus 8y square into dx plus 4y minus 6xy into dy. So when you compare the given equation with the left hand side of the Green's theorem statement, we can easily conclude what is our m and what is our n. So when you conclude, what can we say? So the left hand side of the Green's theorem says that is m dx plus n dy. So the coefficient of dx is our m and coefficient of dy is our n. So in the given equation also the coefficient of dx is 3x square minus 8y square, which is our m. Similarly, the coefficient of dy is 4y minus 6xy, that is our n. So after finding m and n, so for proving the right hand side, we have to find dou n by dou x and dou m by dou y. So we have to differentiate m with respect to y and differentiate n with respect to x. So dou m by dou y is equal to, when you differentiate with respect to y, you get differentiating 3x square, you get 0. Minus differentiation of y square is 2y, so minus 8 into 2y is minus 16y. Similarly, dou n by dou x, which is equal to differentiation of 4y with respect to x is 0, minus differentiation of 6xy, you get 6y. So substituting this in the right hand side of Green's theorem, that is double integral over R dou n by dou x minus dou m by dou y into dx dy, which is equal to double integral. Our dou n by dou x is minus 6y minus dou m by dou y is minus 16y. So that becomes plus 16y. So 16y minus 6y is 10y into dx dy. And the limits are given by, so what is the limit? How will you find the limit? If you want to find the x limit, first of all you have to draw the diagram. So the given equations are y equal to x square and x equal to y square, which is nothing but a parabola. One is looking upwards and one is looking rightwards. So after putting the parabola, you have to find the point of intersection by solving those two parabolas. So when you solve x equal to y square and y is equal to x square, you get the intersecting point capital A to be 1, 1. So if you consider a horizontal strip, you can find the x limit. So x limit is nothing but x equal to y square to x equal to root y. And y limit is nothing but on O you get the y to be 0 and on A the value of y is 1. So y limit is from 0 to 1 and x limit is from y square to root y. So you substitute that. So integral 0 to 1, integral y square to root y, 10y into dx dy. So when you integrate dx, you get x between the limit y square to root y. So on substituting the upper limit, 10y into root y minus y square into dy. So when you multiply this y inside and taking 10 outside, you get 10 into integral 0 to 1, y power 3 by 2 minus y cube into dy. When you integrate y power 3 by 2, you get y power 5 by 2 by 5 by 2 minus y power 4 by 4 between the limit 0 to 1. When you substitute the upper limit 1, you get 10 into 2 by 5 minus 1 by 4 and the lower limit becomes 0. So that is 10 into 8 minus 5 by 20, that is 3 by 2. So 3 by 2 is our right hand side equation. Now let us solve for the left hand side. So left hand side is the line integral. So here we have two lines. One is the line 0 to A, O to A, and another line is from A to O, because here it revolves around the clockwise direction. So along OA we have the equation y equal to x square, and along AO we have the equation x equal to y square. So when you substitute and solve, you get along OA. So integral OA is equal to integral OA 3x square minus 8x square into dx plus 4x square minus 6x into x into 2x dx. So after simplification we are getting the answer to be minus 1 along OA. Similarly along AO we are getting integral AO m dx plus n dy equal to integral AO 3y power 4 minus 8y square into 2y dy plus 4y minus 6y into dy. So y square equal to x, so 2y dy is equal to dx. So that is integral. Here the limit is from 1 to 0 because it revolves around the anticlockwise direction. So integral 1 to 0 6y power 5 minus 22y cube plus 4y into dy. So when you integrate and solve, you get the answer to be 5 by 2. So you have to add both the equation integral OA and integral AO. So minus 1 plus 5 by 2, which is equal to 3 by 2. Hence we get the right hand side and left hand side to be the same value 3 by 2. So our left hand side equation is also 3 by 2 and right hand side also 3 by 2. Hence Green's theorem is verified. Hope you all understand. Thank you.